This is video lecture 6.2 of chapter 6 of the Practice of Statistics, 4th edition, Transforming Random Variables. The goal of this video is just to show you a couple of examples of the effects of linear transformations on random variables. If you have not done so already, you may want to print out the notes copy to follow along with the video. Go ahead and pause the video so that you can do that, and then when you return, you'll be able to follow along. I'll let you read over the scenario, but the gist of it is that we have a random variable x that we've defined as the number of units that a full-time student at this particular community college is taking in fall semester. And then we have the probabilities associated with those particular number of units. So as a quick review, let's make a histogram of the probability distribution and then calculate the mean and the standard deviation. You can key these values into your calculator, or you can make it by hand. What I would suggest is that you pause the video, make the histogram, check it, and check the mean and standard deviation as well. So here you can see the probability histogram. Notice again, we are allowed to put the values in the middle of the bar. I've scaled my y-axis to represent the probabilities, and I've labeled each of those axes to show what they represent. So this is our histogram. As we take a look at the mean and standard deviation, I've shown you those formulas, and our mean is 14.65 units, and our standard deviation is 2.056 units. So you may want to take a few moments to check your work on those to make sure you remember what to do. Now, what we're going to do with this video is we're going to actually take a look at what would happen if we made some changes to the distribution. So in this first scenario, there's a $50 charge for each credit hour that a student takes. So we've redefined a variable t as tuition charge, and we've taken each of the number of credit hours 12 through 18, multiplied those 50, and came up with the tuition charge. So we have values of 600, 650, 700, 750, 800, 850, 900. The probabilities themselves don't change because they are directly connected to how many credit hours these students are taking. So I'm going to show you the probability distribution, which is the table itself, but also show you in the form of a histogram from the calculator what that looks like, and I'll make sure that we talk about how to do that tomorrow. So here you can see what the probability distribution of t looks like, and compare that to what you see above in terms of the probability distribution of x. You'll notice that the shapes are very similar. Now for the mean and standard deviation, I won't show the calculations for those, but I do invite you to go through, calculate those, and make sure that your answers match the ones that I have as well. Hopefully what you found is that the expected value, or the mean, was $732.50, and that the standard deviation was $102.80. And again, this is the graph of the probability distribution itself. So let's take a look at what we may have noticed. In comparing these distributions, x the number of credit hours and t the tuition charge for full-time students at El Dorado Community College, you should have noticed that the shapes of the distribution remain the same. That even though I multiplied every value by $50 to come up with the tuition cost, that did not change the shape of the probability distribution. You should notice that the center, E of x, was $14.65, and E of t was $732.50. Well, E of t is 50 times E of x. So that should let us know that when I multiply every value of a random variable by a constant, that changes the mean by that factor as well. That information should be familiar. You'll also notice that the spread for the standard deviation of x was 2.056, but the standard deviation of t was 102.80. So you'll find that the standard deviation of t was 50 times the standard deviation of x, which tells me that when I multiply every value of a random variable by the same constant, that the standard deviation changes by that factor as well. Now let's take a look at what happens when we have to add a constant to every value. Now the situation is, in addition to tuition charges, which is a realistic situation, every full-time student also has a student fees charge of $100. So we define C to be the overall cost, where we take the tuition charge and add $100 to it. So we see a new probability distribution. Compared to T, all of the values are $100 higher, and so we've added 100 to each value. Again, the probabilities themselves do not change. So take a look at what this histogram looks like. It looks very familiar. By hitting trace, I assure you it's not the same one. These limits go from 700 to 750 all the way up to 1,000. And so you can see that, yes, I've changed the values, but the shape of the histogram itself has not changed. Now let's look at mean and standard deviation. Again, pause the video, take some time to practice the formulas for finding the expected value and the standard deviation, unpause, and then compare your answers to mine. Here's what I hope you found, that the expected value of the overall cost is $832.50, again that is the mean, and the standard deviation of the overall cost is $102.80. That looks familiar. Well, let's see what we notice about the shape, center, and spread of the probability distributions of T and C. As with X and T, the shape of each of these distributions remain the same. They are unchanged. The center, E of T, was $732.50. E of C was $832.50. Notice that the difference between these is $100. So E of C is 100 plus E of T. I've added the same value to the same constant to every value in the random variable distribution, and so my mean has increased by that value as well. For the measure of spread, you'll notice that the standard deviation of T was $102.80, and the standard deviation of C was also $102.80. So that tells me that standard deviation is unaffected by adding a constant, that the distribution is no more spread out than it was before. So let's take a look at what this means on general terms. So in summary, when we multiply or divide every value of a random variable by a constant, then that multiplies all measures of center and location, mean, median, all of the quartiles, all of the percentiles, by the value B, which is the constant that we use to multiply. All measures of spread, range, IQR, standard deviations, are going to divide by the absolute value of B. We understand spread is not a negative number, and the distribution does not change shapes when we apply this transformation. When we add or subtract a constant, the value of A, which is the value of the constant that we're adding, is also added to measures of center, location. Again, the mean, median, quartiles, and percentiles. However, the measures of spread do not change. Range, IQR, and standard deviation will be the same as they were before. Lastly, the shape does not change. If we look at that in proper notation, then if I am adding a constant A, multiplying by a constant B to a random variable X, then the probability distribution has the same shape as it originally did. The new mean takes the old mean, multiplies it by the value we multiplied by, and adds the value that we added. The new standard deviation can be formed by multiplying by the absolute value of the number that we multiplied. Notice that we're not changing the standard deviation by the constant of A, since adding a constant does not change the standard deviation. So with this, we should be able to practice some problems tomorrow in class dealing with transformations, and we will go back to the problem of, would you be willing to play this game for a maximum prize of $200? Make sure you answer the 5 questions at the end of the video, and I will see you in class.